Oh, hello, physics class. Okay, so I mentioned that I was doing number 2 and number 7 of that group work thing. I already did number 7, so I did number 2. I did number 7 first because it was easier. Number 2 is a little bit trickier. So if I did it wrong, please tell me how to do it right, because I'm not sure if I did it correctly. But anyway, here's, I'm going to share my screen real quick so you can just look at the problem, because I read it and I can just do it. There you go. Draw a snapshot for t equals 0.03 seconds from the following history graph for position x equals 1.5 centimeters, assuming the wave is traveling to the left at a speed of 50 centimeters per second. Okay. So first thing I did, I drew it. Takes a long time, so I drew it before the video. I decided not to bore everyone to tears. So it kind of goes, this is hard, it goes down and then up. That's the basics of that. So it's moving 50 centimeters per squared centimeters per second to the left. I'm just going to call that point, Sharpie's dying, 0.5 meters per second to the left. And this is a x equals 1.5 centimeters. I'm going to call that 0.015 meters, just so we can get an answer in meters, because that's what we want. So the first thing to do, let me consult my notes. I had to take copious notes. Okay, so the first thing to look at is when did the wave hit you, or hit the point that you're looking at? So if you look at it, the wave got to me, I guess, wherever, 2.5 seconds ago. Basically, I'm just looking at the width of this thing. This is a d over t graph, or d of t graph, I guess. It hit me 2.5 seconds ago. It is now just passing me. So that's helpful. If it's traveling 0.5 meters per second, then that means it has traveled 1.25 meters since hitting me. I got that by going 0.5 meters per second times the width of it, 2.5 seconds. 0.5 meters per second times 2.5 seconds is 1.25 meters. So that's going to be, the width of our snapshot graph, or a history graph, my bad. Or history. These are so confusing. We're drawing a snapshot graph. History graph, snapshot. Okay, so it is 2.5 seconds past me at x equals 0.0515 meters, going 0.5 meters per second. That means that it is 1.25 meters past x equals 0.015 meters. That's past where our x is. So if we go 1.25 meters past 0.15, we're looking at this right there, and that equals negative 1.235. So that's where it's going to start. This graph, this snapshot graph, that's where it's going to start. So for t equals 0, that's true. But we want it at t equals 0.03 seconds. T equals 0.3 seconds. So we multiply that by the speed and then shift the whole graph to the left because it's moving to the left. Shift the whole graph that way. So we're going to shift it .03 seconds times the speed, which is 0.5 meters per second. And that equals 0.015 meters. So then, I guess now we just draw it pretty much. Oh, wait, starting point. So we determined our starting point as negative 1.235. Now we know how much to shift it by, so you just kind of add these together. Shift it to the left in the negative direction. So you're going to go negative 1.235 minus 0.015. And that equals something. Let me get my calculator out. And 1.25. Yeah, that's right. So our starting point is negative 1.25. There we go. Harder than it seems. So that's where we start. Since it's going to the left, you don't have to reverse it or flip it or mirror it or whatever it's called. So 1.25, I'm just going to pick one. There we go. So that's where I drew the, I don't know if you can see that awkward little hash mark right here. That's negative 1.25. That's what I decided it will be. Arbitrary because I'm the illustrator. Okay. So now the width of it is, I had it, 1.25. 1.25. So I'm going to go, I start out at negative 1.25. I go to the left 1.25. So now I'm at 2.5. 1, 2, 2.5. This goes down 3, has to go down 3, and then up, and then down. And that's how the physics student do.